After seeing a very strange article this morning on spiders, I decided to do a quick video collection on the possible spider Emmys from 2018 and just see where my research takes me. In northern Mexico, a photographer was hiking with his father and they came across what appeared to be a furry black creature taking a nap in a nook on a rocky slope. When they gently stirred the creature to find out what it was, not sure I would have done the same thing. Sometimes ignorance really is bliss. Anyway, this fur ball then exploded into thousands of little spiders. And here is the tell, as far as I'm concerned, that this is some kind of quantum shifting. The photographer then says, "This is the first time I've seen something like this." It turns out that the hairs were in reality numerous legs of thousands of spiders, and they were so close together it looked like a ball of hair. It is believed that these spiders were a type of harvestmen, a harmless, slender-limbed species known to amass in large groups like this, likely as a defense from the harsh sun. The harvestmen appear later on again in this video in another article. At the time of posting this article on giant spiderwebs on a Greek lake in November of last year, the only cases known, as far as I'm concerned, were Australia and Greece. I just Googled Australia because I wanted to add this now to the video and put the link below, and I could remember posting this. What do you know? Now there are reports on giant spiderwebs in Jerusalem, Great Britain, Pakistan, Tasmania, New Zealand, Texas, and Memphis in the USA. Of course there are. As you can see from the images, a large network of spiderwebs stretched over half a mile, blanketing a Greek lake and surrounding town. The dense webs house hordes of spiders and completely drape vegetation, roads, and buildings all over town. Now, this is where it starts to get interesting. The article goes on to say, the webs are the creation of hundreds of thousands of spiders of the genus Tetragnatha, tiny creatures measuring no larger than 0.7 inches. The water-loving arachnids are common to the area and are often referred to as stretch spiders due to their elongated bodies, or also known as orb weavers because of the type of web they weave. While their presence isn't unusual, locals generally don't see them in these numbers. Scientists blame the population explosion on high temperatures and humidity, coupled with the year's remarkable mosquito population boom. Events of this magnitude are rare, but large webs can sometimes be seen in other areas of the country. Biologists report that the phenomenon occurs every 3 to 5 years when the weather becomes unseasonably warm and humid. While the webs are a bit eerie, the plentiful spiders are not harmful to humans. In fact, their presence is actually beneficial due to the fact that they reduce the mosquito population. Russell Watkins from the Department of International Development was travelling through Pakistan when he came across a scene so surreal that stopped him in his tracks. Nothing really prepared us for what we saw when we got there. What we were confronted with was quite spectacular. Every tree and vegetation that you could see for miles and miles was just cloaked with these enormous webs. Silk specialist Chris Holland thinks he has the answer. This is actually, says Chris, a very simple and natural process. Because of the floods in Pakistan at the time, 2010, it forced the spiders to take refuge further up on dry land, and in particular, high land. In this case, the trees. The types of spiders that you see here are sheet web spiders. Here is a funnel web at Lake Tawakoni State Park in Texas. This supposedly happened in 2007. Here they are saying that it's a funnel web. Although no one has given a definitive answer, many spider experts conclude that the stretch spiders are working together to form the massive web. Some say that these webs happen every few years, while others say it is a rarity. There we have typical contradictory information that usually comes with quantum shifting. A field in New Zealand has been covered in a 30-meter weave spider web. The Bay of Plenty was blanketed over the weekend by the natural phenomenon fondly known as spider bum parachutes, or otherwise known as ballooning. Spider expert Dr. Cor Vink said the spider's mass exodus to a higher ground was due to the heavy downpour in New Zealand over the past week. Spiders often do the same thing with shrubs, crops and trees as seen in Pakistan last year. A similar event occurred in Tasmania and southern Australia last year. The rally of high-flying spiders, known as a mass ballooning event, occurs when spiders crawl to the highest points of their habitat, say a fence pole or a tall plant, and send out silk strands that allow them to be lifted on air currents. While unusual for spiders to create a web of this size, experts speculate that recent flooding caused the spiders to seek higher ground. This means many spiders collaborated to produce the massive silken web. Major flooding in the Australian state of Tasmania has forced spiders to evacuate, according to this article, by using silken threads as hot air balloons. These young arachnids, spotted in Tennessee, were throwing out silk to fly to new territory when wind likely grounded them, expert says. A biologist and expert in spider silk, Todd Blackledge, couldn't identify the spider species from the photos available, but he says they could be orb-weaving and sheet-weaving spiders migrating. Spiders, however, need the wind. Please note that sentence. This was in the article, and this is quite significant later. Spiders, however, need the wind to cooperate in order to pull off their remarkable migrations. Precisely what didn't happen in Tennessee. In fact, Blackledge suspects that the sheet-like web visible in photos from Memphis isn't a web at all. Instead, the mass of silken threads are evidence of the spider's failed attempts at ballooning. Cued by favourable conditions, perhaps warm ground temperatures, which could generate updrafts, the young spiders would have tried to send out their ballooning threads at more or less the same time. However, unexpectedly strong breezes could have then blown these threads back down onto the grass over and over again, eventually creating a tangled mat. The spiders here have shrouded entire trees in giant glittering cobwebs on a scale rarely seen in the Middle East. The Sorek watercourse reportedly contains treated sewage, which is rich in nutrients. Lovely. This aids the proliferation of mosquitoes, which then serve as a food source for the spiders, spurring a reproductive boom. It's an exceptional case, arachnophile Igor Armikach, a doctoral student at Hebrew University's Arachnid Collection, told Reuters. So here we have 7 different events of a similar nature, with slightly varying theories and spider species. I'm just saying, right? Apparently, there is some confusion as to what kind of spider is making these. This actually doesn't really make sense to me because can they not see the spiders in the web? So surely they can identify the spider in this way? I don't get it. I don't get why there is so much confusion. One expert says it is an orb weaver, another says it's a funnel weaver, and yet another says sheet weaver. Granted, a funnel weaver can make sheet webs, so that may explain the confusion there. But as I said, why not just observe the spiders themselves? Or maybe this is just a typical example of conflicting history updates whilst quantum shifting is in the making. When I first saw this about 2 years ago, people were debunking it, saying, nope, there is no such thing as flying spiders. It's a hoax. Then it gradually developed into a real thing with history. And since then, I have noticed that the history has also developed. Not the history within the last couple of years. I'm talking about the history of this particular subject that goes way back. Again, for me, this is typical of quantum shifting. First, nobody knew how spiders were doing this. Then the explanations changed to ballooning, but still they didn't know how the ballooning was occurring, and that spiders could only fly a few yards. Now it has become hundreds of miles. But even this information is a little vague. Okay, so they don't fly in the traditional sense, in that they have wings, but they can still fly, or rather paraglide. And the point here is that the history of this phenomenon is gradually changing. Even though the explanation in this article is new, from a new experiment and new data, the pure fact that Darwin, or rather that it is documented that Darwin already knew that spiders could travel thousands of miles, tell me that this has been mandected. This was not the case months before. In July 2018, a few articles came out saying that they had finally figured out that ballooning was basically spiders harnessing electric fields. Some of the articles stated that this was already a theory, but that it just had not yet been proven. This is also an ME to some. Also, what is new is that spiders take to the skies en masse. Just the thought of thousands of spiders simultaneously tiptoeing, preparing themselves to propel themselves into the skies is completely bizarre to me. But this is what is going on now, and this is what they're doing, hence the giant spider webs. So what exactly is ballooning? Well, it's a kind of paragliding, and scientists have now linked it to electric fields, although I do believe they are still not 100% sure how spiders tap into this. In an experiment, a group of spiders was subjected to an environment where electric fields were switched on and off and their behavior noted. When the electric fields were switched on, the spiders would begin standing on the tops of their legs, proudly sticking their abdomens out. This practice is called tiptoeing due to its similarity to the human stance. Spiders only hold this pose when they're ready to balloon away. It was also noted that spiders can detect electric fields. This was seen by the way the tiny sensory hairs on their feet ruffled, much like the way hair rises when rubbed with a balloon, the moment the electric field was switched on. When it was switched off, the spiders would then drop. Shooting strands of silk into the air to create a kind of sail, they then paraglide into the air. Many spiders balloon using multiple strands of silk that splay out in a fan-like shape. Why is it that some days there are large numbers that take to the air, while other days no spiders will attempt to balloon at all? This question remains unanswered. Probably because it's a bloody Mandela effect. Remember the wind thing? Well, in one of the articles that mentions Darwin, it says, quote, Darwin noticed that hundreds of spiders would inexplicably land on the Beagle, even on a calm day, without any wind to blow them on board, unquote. So if this is the case, then why have scientists believed for all of these years that spiders needed wind to balloon? Because in this new experiment, it has been established that they do not need wind. Something doesn't make sense here. And then we have shedding spiders. So this was posted in my Facebook group, and even the original poster, who is not Mandela affected as far as I know, wasn't aware that this happens. Like people, spiders move by contracting muscles attached to a skeleton. But instead of an internal skeleton covered in flesh, spiders have an exoskeleton, a stiff support structure on the outside of the body. Exoskeleton segments are connected together with joints so the spider can move them back and forth. Muscles attached on the inside of the exoskeleton contract to move the legs inward, but spiders don't have any muscles to extend the legs back out again. Instead, they have to force bodily fluids, mainly blood, into the legs to push them outward. If a spider loses too much body water, it can't generate the necessary hydraulic pressure to push its legs out. This is why you sometimes see spiders on their backs with their legs curled up. The exoskeleton is made of several layers of cuticle, a composite material containing various proteins, and chitin, a long-chain polysaccharide, sugar. The chitin and protein molecules are arranged in long chains, in successive layers, like the grain in plywood. This structure makes cuticle extremely strong, as well as highly effective at keeping the spider from drying out. But the material does have one serious drawback. While it's flexible enough for movement, it can't expand like human bones and tissue. In other words, it can't grow. In order to increase its size, the spider has to form a new, larger cuticle exoskeleton and shed its old one, and this is called molting. Molting occurs frequently when a spider is young, and some spiders may continue to molt throughout their life. At the appropriate time, hormones tell the spider's body to absorb some of the lower cuticle layer in the exoskeleton and begin secreting cuticle material to form the new exoskeleton. The new exoskeleton is typically folded to some extent, so it can expand once the spider sheds the older one. The spider also secretes a molting fluid between the old exoskeleton and the new one. Once the new exoskeleton is finished, the spider absorbs the molting fluid. This creates a gap between the two exoskeletons, which makes it easier to separate them. To shed the old exoskeleton, the spider has to bust out from the inside. It increases its heart rate to pump a lot of hemolymph, the spider's blood, from the abdomen into the cephalothorax. The pressure expands the cephalothorax, which pushes on the old exoskeleton until it cracks. The spider flexes its muscles until the old exoskeleton falls away. Typically, the spider does most of its growing immediately after losing the old exoskeleton, while the new exoskeleton is highly flexible. The new exoskeleton is also very soft in this stage, making the spider particularly vulnerable to attack. Many species will lower themselves on a silk line during the molting process, so they're out of reach of predators while the cuticle material hardens.